Hi everyone, in this video we are going to discuss about this idea of volumetric analysis. So this idea of volumetric analysis is very important for the subsequent chapters that talks about aqueous solutions. Right, so one of the important skills of volumetric analysis is to know what is actually going on and to figure out what happened to concentration and amount as we move along. So over here I have a 4-step process, right, where I did the preparation of a solution, a preparation of a sodium hydroxide solution, and I did a titration of HCl on it. Right, so what is going to happen is that I'm going to show you how we can work with all the different amounts and concentrations. So let's start with a very simple diagram. So I'm going to start off with a 100 cm cube solution in a beaker. Alright, and I'm going to dissolve a solid sodium hydroxide into this solution, and there's 0.1 mole of sodium hydroxide. So what happens is that I am going to transfer this into a volumetric flask and top it up to 250 cm cube. Okay. After which I'm going to pipette out into a conical flask, right, 25.0 cm cube. And finally I'm going to do my titration onto the conical flask, and this concentration is 0.1 mole per dm cube HCl. Alright, so what I'm going to be able to find out, alright, is the actual number of moles of NaOH that I've used. So let's follow this NaOH first, and later on we are going to move on from the other side and follow the HCl volume. So for example, alright, if we took the 0.1 moles of NaOH and dissolved it in the solution, I will have 0.1 mole of NaOH, right? But my concentration is equals to 0.1 over 100 divided by 1000, which gives me 1 mole per dm cube. So when I transfer it to 250 cm cube, what you realize is that since I'm transferring everything, my number of moles stays the same as 0.1 mole, but my concentration has been diluted. So since it's diluted, I can use the formula C1V1 equals to C2V2, where the amount is constant. Alright, so you can use C1 will be 100 cm cube times, the concentration is 1 times the volume is 100 over 1000 is equals to the second concentration, the new concentration, times 250 over 1000. So basically our C2 is equals to 100 over 250, which is 0.4 moles per dm cube. Alright, so it is test. Yeah. So our C2 is equals to 100 over 250, which is 0.4 moles per dm cube. Alright, and when I transfer pipette 25 cm cube over, my concentration will stay the same because I did not dilute the solution at all. However, my amount, now will not be 0.1 moles. My amount will now be 0.1 times 25.0 over 250 because I've took out 1/10 of the original mixture. So I have 0.1 mole of sodium hydroxide over here. And after I titrate, I will be able to find out what the volume of HCl is, okay, because they have the same, their stoichiometric ratio is 1:1. So that is for when we move with sodium hydroxide. Alright, so do take note of the concentrations and the amount. On the second case, let's say if I don't know what is the amount of sodium hydroxide that I have, what's going to happen is that I'm going to do my titration. I'm going to get a certain volume here. With the volume of hydrochloric acid, I should be able to use this equation to find the number of moles of HCl. And the number of HCl is equals to the number of NaOH because their mole ratio is 1:1. Then I will move back. Okay, so let's call this value X. So if I were to reverse the reaction, reverse the entire process. Let me erase this off first. Okay, you will realize that this value x is the same value x over here. Alright, and the concentration will now be x over 25.0 divided by 1000. But if I transfer it backwards, if I move back one more step, you'll realize that now n is equals to 10x, because just now we realized that we took 1/10 of it out. Now we have to multiply it by 10, but the concentration stays the same, x over 25.0 divided by 1000. And when I transfer it back again, alright, now my concentration changes. Right, so you can once again use C1V1 equals to C2V2 to calculate a more concentrated solution, but your amount still stays the same as 10x, and 10x should be equals to the amount that you have added. Right, so what I've just shown you is how you can use volumetric analysis to explain your answers in two different directions. Either from the side where you dissolve a solid all the way through the dilution to titration, or using the titration results and work backwards. So these two methods are very important. Please make sure you master them before you can move on to subsequent chapters that talks about aqueous solutions.